Hello friends, welcome back to the channel. In the previous video, we explored two important Kubernetes controllers, the replication controller and the replica set. We learned how they maintain the desired number of pod replicas and ensures that the application stays running even if individual pods fail. So today we are moving one step forward and discussing what is deployment, why do we need deployment strategies. So when we deploy application in Kubernetes, we do not create replication controller, replica sets or pods directly. Instead, we write a deployment manifest file and the deployment automatically creates and manages replica sets and pods for us. But before we go into the manifest, let's talk about something very important. Now, why do we need a deployment strategy in Kubernetes? Let's say you have a Django application running in a production with multiple pod replicas for load balancing and high availability. Now, a new version of your application is released. For example, version 2.00 is ready now, and you need to update your running application without interrupting users. If you follow a traditional approach where you uninstall the older version completely and install the new version of application, and this upgrade takes about 10 minutes, your application will be down for 10 minutes. So this leads to multiple serious issues. For example, application downtime. Users cannot access your application while the old version is removed and a new version is getting ready. Bad user experience. Users may see errors, slowness and completely unavailability. That may lead to reputation loss. In today's world, users expect applications to be available 24/7 and revenue loss. Especially for banking, e-commerce, bookings, subscriptions like applications, every second matters. So that may lead to revenue loss. This is exactly why Kubernetes provides deployment strategies like rolling update, which is the default one, recreate, blue-green, and canary. These strategies help us to update applications smoothly, safely, and without downtime. Let's understand rolling update. By default, Kubernetes uses rolling update strategy. I will show you this in the demo section, but we can validate it using kubectl describe command where we can grab strategy type. So that is rolling update. Rolling update replaces pods one by one, ensuring zero downtime, smooth upgrade, continuous application availability. So let's understand rolling updates with a very simple and a practical example. Suppose you have a Django application running in production with 4 replicas and the current version is 1.0.0. Now your developers have released a new version 2.0.0, and you apply the updated deployment manifest. Suppose you run kubectl apply -f deploy manifest.yaml. The moment you run this command, Kubernetes begins the rolling update process. Here is what actually happens behind the scene. Kubernetes first creates a new pod running the new version 2.0.0. It doesn't touch the old pods yet. Kubernetes waits patiently until new pod reaches its running state and the readiness probe is successful. Only when new pod is completely ready to serve the traffic, Kubernetes moves to the next step. Once a new pod is ready, Kubernetes terminates the old pod of version 1.0.0. Now your cluster has 3 pods of version 1.0.0 and 1 pod of version 2.0.0. Next step, Kubernetes again creates a second pod of version 2.0.0, waits for it becomes running or ready state, and then terminates the another pod of version 1.0.0. This cycle continues, like create, then wait, then terminate. Again create, then wait, and then terminate, until all pods are replaced with the new version. By the end of rollout, all 4 pods will be running version 2.0.0 and at no point was your application completely down. This is the power of rolling updates, smooth, controlled and zero downtime deployments. Now, if something goes wrong after an upgrade, Kubernetes lets you to roll back to the previous stable version. Finally, when you want to make multiple changes to your environment, such as upgrading the underlying application version, scaling the environment, modifying resource allocations, you can pause the deployment, make the changes and then resume it. So all updates are rolled out together. All of these capabilities comes built in with Kubernetes deployment. So far in this course, we have discussed pods, which deploy single instances of our applications. Each container is encapsulated inside a pod. Multiple such pods are managed using ReplicaSets, and then comes deployment, which is the Kubernetes object and sits higher in the hierarchy. A deployment provides the ability to seamlessly upgrade the underlying instances using rolling updates, undo or rollback changes, and also pause and resume changes if needed. How do we actually create a deployment? Let's go to Visual Studio Code, where our Kubernetes playlist repo is available. Today's deployment related manifest file will be under day 8 folder. I have created a file called deploy-definition.yaml. Now let's see the YAML file instructions for deployment. Just like the previous components, we start by creating deployment definition file. The structure of deployment manifest is almost identical to ReplicaSet manifest. The main difference is kind, which is now deployment instead of ReplicaSet. Like all other Kubernetes manifest files, a deployment file also has same 4 sections: API version, kind, metadata, spec. API version is apps/v1. The kind is deployment with decaps. The metadata section is just like other manifest. It includes name and the labels. For this demo, I am using Django application, and the images for different versions are already available in my Docker Hub. So this is my Docker Hub repository. This application we are going to use sehsolutions, and all the versions are available here. So, this is my Docker Hub repo, and sehsolutions is my app name. Using this app, I will show you how to roll back to a previous version. So let's give labels as app name as sehsolutions, and deployment name is sehsolution deployment, and the type is Django. Now in the spec sections, we place the pod definition because deployment ultimately runs pods. So we provide pod name, and labels app as sehsolutions, and the type is Django. Inside containers, can give name as application name, and the image, let's copy the image. And use the version 200. Since our application is using port 8000, we can see in expose map 8000. Let's use the port 8000 here. Next, set replicas to 3, that is okay. And then in selector to match the pod labels. So here we match with app is equal to sehsolutions. Once the deployment file is ready, push the changes to Bitbucket or GitHub under your Kubernetes repo. It's always a good practice to use version control system. I'm using GitHub, and I will share the repo link in the comments. After that, git add dot to add your changes to staging area, git commit to commit your changes, and push. Once it is done, in your Kubernetes master, I'm already having Kubernetes playlist repo available here. Just do git pull. CKAD to day 8 and deploy definition.yaml. So my deployment definition YAML is ready. Before creating the deployment, let's check what's currently in the cluster under the default namespace. For that, kubectl get all. Usually, we only see default Kubernetes service. Now to create a deployment, run kubectl create -f -f flag simply means you are providing a file. You can also use kubectl apply -f then the file name. See, the difference between create and apply is create only creates a resource for the first time. Apply can create and update resources based on the file. This is the declarative approach. To verify your deployment, you can do kubectl get deploy. So here, the number of pods you asked for 3, and how many pods are running? 3 out of 3 pods are ready, or 3 pods are up to date. And how many pods are healthy? 3 pods are healthy. Available means 3 pods are healthy. A deployment automatically creates a replica set. So run kubectl get rs. You will see replica set with the deployment name. Replica sets then create the actual pods. To check, then we can run kubectl get pods. The pod name starts with the deployment name, then the replica set hash, this one, and the final 6-digit random code. To view everything together, we can run kubectl get all. So here we have 3 pods running, 1 deployment and 1 replica set. Since we don't have a service running yet to access the application from outside the cluster, we can use port forwarding to check inside the cluster whether the application is coming up or not. To access the app from outside, we will need to create a service, but for now port forwarding is enough for testing. The command is kubectl port -forward and then pod name and the port numbers. Here is what it does. This kubectl port forward tells Kubernetes to forward traffic from a local port to a port on a pod. This sehsolution deployment and then this hash code, this is the pod name you want to forward traffic to. This 8000:8000, the first 8000 is the local port on your machine and the second 8000 is the port inside the pod where the application is running. So after running this command, any traffic you send to localhost :8000 on your machine will be forwarded to the port 8000 on the pod in your deployment. Since we cannot access the application in the browser using http:/server IP :8000, let's access it directly on the master node by forwarding to localhost. Just run curl then http:/localhost:8000. So this will help us to confirm that application is running correctly before we create a service. Now let me show you something very important, how to roll out a new version and how to roll back if something goes wrong. This is one of the biggest advantages of using Kubernetes deployments. Let's say developers have built a new version of our application, the latest sehsolutions image. And they have pushed it to Docker Hub. So this is my Docker Hub repository for sehsolutions and the latest version has been pushed here. To roll out this new version, all we need to do is to update our deployment manifest with a new image tag. Here to vim deploy definition.yaml and update the version to latest. Once the manifest is updated, open a second terminal of your master node here and run kubectl get pods -w. So this command watches the pods in real time. Now apply the updated deployment file using kubectl apply-f deployment definition.yaml. The moment you apply the changes, you will see a beautiful rolling update happening in our screen. So here, new pods are getting created and old pods are getting terminated one by one. This ensures zero downtime updates. Your application stays online throughout the rollout. So here, something like this, new pod pending and container creating and running, old pod terminating and completed. This continues until all pods are updated to a new version, and once everything stabilizes, your upgrade is complete. If you do kubectl get pods, 3 out of 3 pods are running. Kubectl get deploy, our deploy is ready. Kubectl get ReplicaSet. Now imagine something goes wrong, maybe a bug, maybe a broken API call, and we want to return to the previous stable version. So Kubernetes makes it super simple. To roll back to version 2.0.0, just run kubectl rollout undo and then deployment and deployment name, enter. Kubernetes immediately switches back to the last working replica set. Your pods will again be terminated and recreated, but this time with the older image version. That's the power of deployments, smooth upgrade, safe rollbacks and zero downtime. So if you do kubectl get all, three pods, deployment, and now this is our new replica set. So here you can match this hash code with the pods hash code. So before we wrap up this video, let's discuss one important command and also attempt a CK style practice question. So how to change the image in deployment to this one from the existing one. First, let's verify what image is being used. In your master node, run kubectl get deploy and then kubectl describe deploy and then deployment name. So here in the deployment under container section, so image currently is 2.0.0. We need to update this to 1.0.0. So for that we will use kubectl set command. The command is kubectl set and then image and then deployment name, deploy and then deployment name sehsolution deployment, solutions deployment, and container name is sehsolutions is equal to new image name. Copy the image and paste it. Deployment. Once done, image updated. So here in this kubectl set image command, this sehsolutions deployment, this is my deployment name, sehsolutions, this is my container name, and this is the new image. Once done, we can validate kubectl get deploy and then kubectl describe deploy and deployment name. So here again under the container section, we can see now image being updated to 1.0.0. This ensures the new image is rolling out properly. Now let's take a CKA practice question with respect to deployment. So you have an existing deployment name front-end deploy in prod namespace which is having 5 replicas running. We need to scale it down to 2 and they change the image to 1.25, and this question carries 4% weightage in the exam. So first of all, let's create a lab setup. For that, on the master node, create a deployment, kubectl create deployment or deploy, then deployment name, which is front end deploy, and hyphen image is equal to, we need to use the image nginx. Let's use some older version, 2.4, hyphen replicas. As per the question, replica should be 5, and hyphen namespace is equal to prod. Since we don't have a namespace ready yet, so it will throw us an error. So prod not found. Before that, create a namespace, kubectl create namespace name is prod. It created. Now again run the command. Just validate kubectl get deploy, kubectl get deploy hyphen n prod namespace prod. So here for this deployment in prod namespace, 5 replicas are running. So you can modify the existing deployment directly using the kubectl deploy command, kubectl edit command, and kubectl edit and then deployment name, and inside the editor we can change the replicas and hyphen n prod. Don't forget to enter the namespace as well. So here under spec section you can see replicas currently are 5. We need to update it to 2. Also image, also in the image section, currently the image is 1.24. Let's update it to 1.25 as this is being asked in the question. Save and exit. So Kubernetes will automatically trigger the rollout. We can validate kubectl get deploy hyphen n prod. So on the prod, now replicas being scaled down to 2. And inside kubectl describe, inside the deployment using kubectl describe, kubectl describe deploy deployment name in the namespace prod. Here we can validate the image name. Image is now 1.25. The another method to scale down and change the images, kubectl scale command. So before that, let me roll back the changes using the edit command itself. Here replicas, let's make it to 5 again, and the image roll back it to 1.24. Save the changes being edited. Now use the scale kubectl scale command to scale down the pods from 5 to 2. Before that, let's validate kubectl get deploy hyphen n prod. So now we have total number of pods. Our pod replicas are 5, but ready for it will take some time. We can apply hyphen watch. Okay, now we have 5 out of 5 pods are ready. Now use kubectl scale command, scale then deploy and then deployment name hyphen replicas is equal to 2. From 5 we need to make it 2, that is mentioned in the question, and the namespace is prod. Scale, let's do kubectl get deploy again. So now 2 out of 2 are ready. And to update the image, we can run the command kubectl set image and then deploy. You can write deploy space deployment name or deploy slash deployment name, and the container name is Nginx. We can validate it from here. The container name is Nginx is equal to the image name, which is Nginx 1.25, and the namespace is prod. Hit enter. Once done, image updated. We can validate using kubectl describe deploy in the namespace -n prod. So here image being updated to 1.25, and we have 2 replicas. Let's take one more question. Need to autoscale the deployment front-end deploy in the prod namespace at 80% CPU with minimum replicas 3 and maximum replicas 5. So let's do it using kubectl autoscale command. kubectl or -n prod namespace, then autoscale deploy, and then deployment name, and -- minimum is equal to 3, -- max is equal to 5, -CPU %, is equal to 80%. Hit enter. See, horizontal pod autoscaled. To validate kubectl get HPA horizontal pod as autoscaler in the prod namespace. So this is exactly how these types of questions appear in the CKA exam. So make sure you practice them well. If you face any issues while working with Kubernetes, feel free to reach out. I'm always happy to help. Thank you so much for watching. Please like, share and subscribe to support the channel and keep me motivated to bring more content for you. In the next lecture, we will explore Kubernetes services, an extremely important and interesting topic. Thanks again and see you in the next video.